Hello everyone. Yesterday we went over the basic scalar and vector quantities and how to really think about them, how to imagine them as magnitude versus magnitude and direction. Today we're going to go over the units for these, and we're also going to go over a little bit on the formulas, the basic formulas that you use for mechanics. And these formulas come up over and over again, no matter if you're doing mechanics, even though mechanics makes up almost like, I would say 70% of the problems you're doing. But even if you're moving on to a different chapter, a lot of these formulas keep on coming up and up because they're all related. So for a lot of these, what you have to notice, or almost actually all of them, is that none of these are written in the imperial system. The units are not written in the imperial system. They're all written in the metric system or in the SI units, which are a lot of times just interchangeable. So for distance and displacement, we have meters, and this is written as an M. So you're never gonna write distance on the unit be a D. That wouldn't work. You have to write meters with M. So you're gonna have to say for a distance of 3 meters, you would say 3M. And it's the same thing for displacement. Although for these vector quantities, remember you have to have your direction attached. For speed, it's just gonna be distance over time. So we use the distance unit, which is meters, and then our time, which is always, or in most problems, the standard is that it's gonna be in seconds. And occasionally it might be written in hours or minutes, but that comes up very rarely. For velocity, it's the same thing as speed, and that occurs because we use the distance units over time, and here we're going to use displacement units, which are the exact same as the distance units. So these are also going to be meters over seconds. For acceleration, it's going to be velocity over time. So the units for velocity are meters per second, but then it's velocity over time, so then you have to put meters over second, and you write that in a lot more easy to read way as meters per second squared. Alright, now for some of our equations. A lot of our equations revolve around, so if you notice, like velocity displacement over time. Displacement can also be written many times as change in x. This isn't the unit, this is the way that they write it. So, for example, velocity can become v and acceleration can become a. Mainly you focus on vector quantities. Scalar quantities don't come up nearly as much. But for speed it would be s, and for distance it would just be d again. But remember, that's not the units, that's just a shorthand for the actual word. So a lot of the most basic equation that you see is going to be, because you have velocity displacement over time, then you have v is equal to change in x over t. Make this into a separate box here. So what this just means is v, remember, just stands for velocity. And the change in x, so x stands for distance, or d. Either way, you have change in x or change in d, and that signifies the displacement, because x is position. The next one that you have is acceleration. If you look here, acceleration is velocity over time. So now we just have change in x over t again. So that's just going to be change in x over time squared. So x is position, so it's going to be your change in it's just going to be your displacement over time squared. And that covers it for the most basic equation that you have here. It is just going to be the velocity is change in x over t. That's going to be the most important one, and acceleration change in x over t squared. Or if you look at it as well, right here is change in x over t. Remember, this is velocity. It's just velocity over time. Change in velocity. So acceleration is going to be change in velocity over time. So this right here and this right here are the two most basic equations that are going to keep coming up, and from this is kind of what we build the other equations from. Thank you for that. Tomorrow we're going to be going over even more equations.